Look up. Feel the warmth on your skin. That gentle heat has traveled an astonishing 150 million kilometers to reach you. It comes from our star, the sun. It is the most familiar object in our sky, a constant presence in our lives. We see it rise and set each day, a reliable beacon marking the passage of time. But it is so much more than just a bright light. The sun is the anchor of our solar system, the gravitational heart that holds everything in its orbit, from the largest planets like Jupiter to the smallest asteroids drifting in the void. It is our cosmic parent, the source of nearly all the energy that sustains our world. Every ray of sunlight that falls upon the Earth carries with it the energy for life. It is this energy that plants capture through photosynthesis, forming the very foundation of the food chain that supports almost all living things. The light from the sun dictates our seasons, drives our weather patterns, and illuminates our world. Without it, the Earth would be a frozen, lifeless rock, adrift in the eternal darkness of space. The story of life on our planet is inextricably linked to the story of this magnificent star. It is a connection that stretches back billions of years, a constant dance between a world and its sun. Think about it for a moment. Every meal you have ever eaten, every breath of air you have ever taken, can be traced back to the energy produced by our star. The fossil fuels we have used to build our civilization are nothing more than ancient sunlight, stored away by plants millions of years ago. The sun's influence is woven into the very fabric of our existence. A profound and beautiful truth. It is the reason our planet is not just another barren world, but a vibrant, teeming oasis of life, a pale blue dot full of wonder, powered by a star. It is the ultimate source of our existence. This journey to understand the sun is, in many ways, a journey to understand ourselves. By studying this star, we learn about the fundamental processes that govern the universe. We explore the nature of matter, the incredible power of energy, and the delicate balance of forces that allow planets like ours to exist. The sun is our closest laboratory for studying astrophysics, a place where we can witness the awesome power of a star up close. It offers us a window into the workings of the cosmos, reminding us of our place within a much grander, more spectacular universal story. The sun may seem like a small, manageable disk in our sky, but this is a grand illusion created by immense distance. In reality, it is a celestial object of almost unimaginable size and scale. It is so vast that you could fit approximately 1.3 million planets the size of Earth inside it. Imagine filling a giant beach ball with tiny grains of sand. That gives you some idea of the comparison between the sun and our world. It is a truly humbling thought, a stark reminder of how small our home is in the grand scheme of the solar system. Our entire planet is just a speck when compared to the colossal sphere of our star. Its size is matched by its incredible mass. The sun accounts for a staggering 99.86% of all the mass in our entire solar system. Everything else, all the planets, moons, comets, and asteroids combined, makes up just a tiny fraction of the remaining 0.14%. This immense mass is what generates the sun's powerful gravitational pull, the force that keeps Earth and all the other planets locked in their steady, predictable orbits. It is the sun's gravity that sculpted the solar system, dictating the dance of worlds around it for billions of years. Without this overwhelming mass, our cosmic neighborhood would simply fly apart into the cold emptiness of space. To put its dominance into perspective, think of Jupiter, the largest planet in our solar system. Jupiter itself is a giant, more than twice as massive as all the other planets combined. Yet, even this behemoth is utterly dwarfed by the sun. The sun is more than 1,000 times more massive than Jupiter. It is the undisputed king of our solar system, a body so large and so heavy that its influence extends far beyond the outermost planets, reaching out into the distant realms of the Kuiper Belt and the Oort cloud. Its sheer scale is difficult for the human mind to fully comprehend. This enormous scale is fundamental to what the sun is and what it does. Its immense mass creates incredible pressure and temperature deep within its core, conditions that are necessary for the stellar magic that powers it. A smaller body simply could not generate the forces required to ignite the nuclear reactions that make a star shine. The sun's size is not just an impressive statistic, it is the very reason it is a star at all. It is a perfect example of how, in the universe, scale can determine destiny, transforming a simple ball of gas into a radiant source of life and energy for an entire system of planets. So, what is this magnificent celestial body actually made of? The sun is not a solid rock or a ball of liquid fire as ancient cultures once imagined. Instead, it is an enormous, searingly hot sphere of plasma. This plasma is composed almost entirely of the two simplest and most abundant elements in the universe, hydrogen and helium. About 74% of the sun's mass is hydrogen, and about 24% is helium. The remaining small percentage is a mix of other elements like oxygen, carbon, and iron, which were forged in the hearts of previous generations of stars. This composition is key to understanding its incredible power. The real magic happens deep within the sun's core, a region of unimaginable extremes. Here, the gravitational pressure from the star's own immense mass is so intense and the temperature so high that it reaches an astonishing 15 million degrees Celsius. In this environment, the atoms of hydrogen are stripped of their electrons and move with incredible speed. They are squeezed together with such tremendous force that they overcome their natural repulsion and fuse together. This process is called nuclear fusion, and it is the engine that has powered our sun for more than 4.5 billion years, and will continue to do so for billions more. Nuclear fusion in the sun's core is a beautifully simple, yet profoundly powerful reaction. In essence, 4 hydrogen nuclei are slammed together to create one helium nucleus. What is truly remarkable is that the resulting helium nucleus has slightly less mass than the 4 original hydrogen nuclei combined. This tiny amount of missing mass has not simply vanished. It has been converted into a tremendous amount of energy, as described by Albert Einstein's famous equation, E equals mc squared. This energy, born from the transformation of matter, is what makes the sun shine and what ultimately gives life to our planet. This process is a continuous, self-sustaining reaction. The energy released by fusion pushes outward, creating a pressure that perfectly balances the inward crush of gravity. This delicate equilibrium is what keeps the sun stable, preventing it from collapsing under its own weight or exploding. Every second, the sun converts about 600 million tons of hydrogen into helium, releasing a torrent of energy in the form of light and heat. This energy slowly makes its way from the core to the surface over thousands of years before finally radiating out into space, beginning its 8-minute journey to Earth. The sun is not a perfectly calm and uniform sphere. Its surface is a dynamic, turbulent place, home to dramatic events that can have far-reaching consequences. Among the most spectacular of these are solar flares. These are sudden, intense explosions of energy and radiation from the sun's surface, often occurring near sunspots, which are cooler, darker areas caused by complex magnetic fields. A single solar flare can release the energy equivalent of millions of hydrogen bombs exploding at once. These events are a breathtaking display of the raw power simmering just beneath the sun's visible surface, a reminder of its volatile nature. When these powerful flares erupt, they can hurl vast clouds of charged particles and magnetic fields into space. These are known as coronal mass ejections, or CMEs. If a CME is aimed towards Earth, it can interact with our planet's own magnetic field, the magnetosphere. This interaction creates beautiful phenomena like the aurora borealis and aurora australis, the northern and southern lights. However, these solar storms can also be disruptive. They have the potential to interfere with our satellites, disrupt radio communications, and even overload power grids on the ground, posing a real challenge to our technologically dependent civilization. Understanding this space weather is becoming increasingly important as we venture further into space and rely more heavily on satellite technology. Predicting the sun's activity, from the cycle of sunspots to the likelihood of a major solar flare, is a key field of modern science. By studying the sun, we are not just satisfying our curiosity about a distant star, we are also taking practical steps to protect our way of life. The sun gives us life, but it also possesses the power to disrupt it, and learning to live with its more violent moods is one of the great challenges of our time. Our journey to understand the sun is far from over. It remains an object of immense wonder and profound mystery. We have sent probes to study it up close, peering into its atmosphere and measuring its solar wind, yet so many questions remain. How exactly does its complex magnetic field work? What causes the 11-year sunspot cycle? The sun is our constant companion, the source of our warmth and life, yet it still holds its secrets close. It is a beautiful reminder that even for the most familiar objects in our universe, there is always more to discover, more to learn, and more to be inspired by.